Hello and welcome to SudoKanard. We're here to solve this puzzle by Richard Stolk, the Dutch Sudoku professor. And this is called Little Palindromes. So what is happening here? So this is not quite a little killer. By this I mean that 9 is not necessarily the sum of those digits. And actually it's not possible with the rules. It's the sum of some digits that appear consecutively along this diagonal and that form a palindrome with at least 3 digits. And it will be exactly 3 digits with an odd digit in the middle. It could be, for example, 1, 7, and 1. Let's see. 1, 7, and 1. Hey, what is happening with my arrows? It could be 1, 7, and 1 like this, or it could be 2, 5, 2, or 4, 1, 4, for example. And this 4 clue here will be something like this 1, 2, 1 at some point. Sorry about that. So how are we doing this? 61 looks like the place to start. 7 digits summing to 61. The average is almost 9. This must be the maximum value. Let's try the maximum value. Maximum value here is 61. That's correct. What about 35? Is it the maximum value? Let's try the maximum value with 6 and 7 here and 9 there. That is 35, all right. So it is ambiguous, the 9 pairs here. What about 24? The maximum value would be with 3, 4, 5 here, and that is 24. We're left with 1s and 2s here. Okay, so that is that was definitely the place to start. And now we must proceed with this. This palindrome will definitely not be of size 4 because then those 2 digits would be equal, which is definitely forbidden. So we have a palindrome like this or like this with an even digit in the middle. It could be 3, 2, 3, or it could be 1, 6, 1. Well, there are a number of options. Oh, this 4. Oh, this is 1, 2, and 1 like this. That's the only possibility of achieving this 4. So now this 8, this 8 doesn't use a 1. It couldn't be 3, 2, 3. It could be 3, 2, and 3. And I'm starting to think that this is the only option. Yes, that's the only option. 3, 2, and 3. And by the palindrome property, 3 goes there. Oh, and by the way, this one turns this into a 2. And this, that's a 2, that's a 1. So, oh yes, that's interesting. Now the 9 is necessarily 1, 7, and 9, and because of this, the 1 is here and the 7 is there, which disambiguates the 6, 7 pairs. Now, let's do some Sudoku. Yes, we're solving Sudoku after all. So are we now using this 12th clue? We could definitely have 5, 2, and 5. Yes, that would work. We could have 2. No, we couldn't have 2, 2, and 8. And we can't have a palindrome here because those digits are different. Oh, it could be more than 2 cells. It could be... Or could it? Yes, no, it couldn't be 4, 2, 2, 4. It couldn't be 2, 2, and identical digits in between. So I think that 5, 2, and 5 is the only valid option. It's always a little confusing. There's always the chance that I've forgotten an option, which is generally what happens when I solve during a contest. Okay, so this column still needs for 8 and 7. And this row still needs 1, 2, 4, 8. This row needs 5, 6. Oh, 5, 6. Yes, this is 5 or 6, so this is from 2, 4, and 8. And there are quite a number of options for these digits. Now, 28 will require at least 4 digits. 2 are not enough. It won't be 7997, definitely. Oh, it could be. No, it couldn't be 79. It couldn't be of length 5 because it would be too much. So, and it couldn't be like this, so it will be like that. With a 9 here. Oops. And those digits are identical, and there must be 5s to get to a sum of 28. That's a 6, that's a 5, that's a 6. And here we need 3 and 7. So this 26 is done now. What about this 6? 3 digits summing to 6. They won't be 2, 2, and 2. They won't be 1, 2, 3. There must be some repeating stuff. 1, 4, 1. 1, 4, and 1 seems to work. Oh, that's the only option, actually. That's the only way of achieving this. Of achieving this 6. So we are nearly there. There's a 1 here by Sudoku. Those are from 2, 4, 8. There's a 6 somewhere here. So there's this 16 and this 36 to resolve. This row needs 3, 6, 7, and 8. What about this column? It still needs 3, 7, and 8, so that's a 3. This row needs 2, 3, 7, 8, so this is 2. This is 7 or 8. 3, 7, 8 there. 7 and 8 here, so 1 goes there. Here I need 4, 5, and 6. 5 goes there. Those are 4 and 6. That's a 3. 3, I said. The column still needs a 9. This is 2 or 6. This is from 2, 4, 6. 4, 6, 7, 8. Now it's important to have the candidates on this diagonal. So those are also 6, 7, 8. So now this 16 should be doable. A 6 here would work. We would have 5, 6, 5 like this. And we can see that actually that seems to be the only option. 3, 5, 3, 5 would make 16, and this would be more than that. So 6 here is the only option for this 16 sum. Okay, that's, here is a 4. That's not a 6. And we are left with this 36 clue. How do we achieve this? 8 here would make 28. That's not enough. 5 can't be in a palindrome. A palindrome centered on 6 wouldn't work. That would be too much. Something is not working. Eight, 7, 6, 7, 8. Oh yes, that would work. 8, 7, 6, 7, 8 would be 36. All right. It would resolve a lot. That's a 3, that's 8, that's 2, that's 2, that's 3, that's 7. And we're done with the variant. So now it is just classic Sudoku. So 4 and 8 here, 8 there. So those are 4s, those are 8s, this is 4. Here I need 8 and 6. Up there I need 2 and 5. That is a 3. This is 9. This is 6. This is 4 and this is 5. Yes. Well, puzzle doesn't include solution, but I think that what I've done works. Like this puzzle? Yes, I did. All right, so little palindromes. So there was, as usual with Richard, a clear, definite solving path, and I think that this is what I have found. Thanks for watching this video. See you soon on SudoKanard.